Greetings to Group 7. I hope the activity is going well, my fellow physical scientists. Please listen carefully to complete your task. What should a scientist notice about how an object moves when it is pushed or pulled as it relates to balanced and unbalanced forces? Here is an example. Dr. Rivera watches the data, not just the cart. When she pushes or pulls, the first clue is the velocity time graph. A flat line means the cart's speed isn't changing. Balanced forces, net force 0. A sloped line means speed is changing. Unbalanced forces, net force 0. At the very start, she often sees nothing move, even though she's pulling. The force sensor climbs until it crosses a threshold, then motion begins. She notes that the plateau was static friction balancing her pull. The sudden movement shows that friction could no longer match. Forces became unbalanced, so the cart accelerated. Once the cart is gliding, Rivera eases her hand until the force sensor reads just enough to match kinetic friction. The graph settles into a flat line again. Constant velocity under balanced forces. If she turns the cart or nudges it sideways, the direction changes even if speed doesn't. That counts as acceleration, so there must be a momentary net force inward. The following describes what happened. Bigger leftover, net force at the same mass. Bigger slope on the velocity graph. Bigger mass at the same net force, a gentler slope. To stop smoothly, she applies a small, opposite pull until the velocity returns to 0, then trims the force to re-establish balance so the cart stays at rest. Your task as a group is to create your own example of balanced and unbalanced forces when it comes to pushing an object. 1. Assign one person to video the process of creating the example, the conversation involved with detailing the example, and a discussion about the wider implications for building a roller coaster. 2. Assign one person to lead the creation of the example using the manipulatives for each group. 3. Assign one person to write the narrative for the video. 4. Assign one person to use their computer and classroom notes to develop the wider implications. How can the concept of your example be used in designing a roller coaster? 5. The person filming the video will save the work to their computer. 6. The person filming the video will email the film to Khalil and Doc Ceased.